All right, students, in this video, I'm going to go over the notes of Introduction to Matrices and Row Operations. This video is going to have two sections because you need to learn how to write a matrix. So I need to explain to you how or what a matrix is first, and then how to write the matrix. And then after you master writing the matrix, the second part of that is knowing how to do row operations with the matrices. So the first part is understanding what a matrix is. A matrix is technically a system of equations written with just the coefficients and constants. So what that looks like in Algebra 1 is if you had the system of 3x minus 2y equals 2 and negative x plus 4y equals 5. In Algebra 1, you had two equations that had x and y, and you had to solve for x and y. But in order for us to proceed to what's next, the methods of Algebra 2, elimination, and technology, we need to learn how to write matrices. So if you notice, I just write the coefficients in there and that last number of the constant there. Negative 1 is there, so there's negative 1, 4, and 5. So this is the Algebra 1 version of a matrix, and this is the Algebra 2 version of a matrix. So let me write that down. You will have 2x minus 5y plus 3z equals negative 1. That's the first row. This will be what the equation looks like, and this is how it looks like in a matrix. Then you will have negative 4x. The 0 means that there's no y, and then the 2 means that that's the value of the z, so we're going to have positive 2z equals negative 2. The last row says 0 on the first part, so that's 0x, so we don't write an x, and then we proceed with negative 2y minus 4z equals 1. So if you didn't see or know about matrices, this is what it would look like. Three equations, x, y, z for the first one, no y value for the middle one, and no x value for the last one. And when you write it as a matrix, it will look like that. So your job is just to recognize what are the rows, what are the columns, and if you're doing a 3 by 4 or a 2 by 3. But in Algebra 2, we're mostly doing this one because we have the x, y, z, and then it equals a number. So now that you know what a matrix is, we need to emphasize that these are called augmented matrices, and they are created by following this order: A, B, C for the coefficients, and D for the constant. So I can color coordinate for you just so you can see the difference. And I'm going to have orange for the A, blue for the B, green for the C, and purple for the D. So A, B, and C are the coefficients of x, y, z. And then the letter D stands for the constant, which is the last number. Sometimes you're not going to have equations in order. You're going to have x's or y's on the right side. You're going to have numbers that are constants on the left side. Your job is to rewrite them to follow this order before you convert them to an augmented matrix. So notice that all of these are in order. X, Y, Z on the left side of the equal sign, a constant on the right side. X, Y, Z on the left side, a constant on the right side. X, Y, Z on the left side, a constant on the right side. So kind of like seeing where the equal sign is will tell you whether they're in order or not. If they are, you may proceed to writing all these coefficients by themselves and the constant there, and repeat the same with the other two. Keeping in mind that the first column is x, second column is y, third column is z, and the last column is constant. So what we're going to do is, before we talk about the bottom part of these notes, is practice. We're going to practice writing a matrix and then writing a system from a matrix. So the first example has the equal sign here, here, and here. So notice that on the right side, we just have constants. And on the left side, we have x, y, z, x, y, x, y, z. So we only have variables, which is good. This one is ready to be written as a matrix. When you write the matrix, keep in mind that you want to go in the order of x, y, z, and then the constant. So the first one, no number next to the variable means we have a 1. 1 right there, 1 right there, 1 right there, 1 right there. So we're going to write a 1 for the x. The y is a -1. The z is a -2. And the constant is a -6. Let's do the next one. X has a 3. Y has a 2. And this one does not have a z. So we're going to put a 0 because there's no z value. And then -25 at the end. The last row has -4 for the x, a +1 for the y, and a -1 for the z. And the constant is 12. So this is how you will write the matrix for that first example. All right, let's take a look at the second problem here and highlight, or I'm going to highlight, where the equal signs are at. These equal signs tell me that this one's not ready to be converted to a matrix yet, because we need to write it in the order of ax plus by plus z equals d. It has to be in that order. So the first one looks like x, z are on the left side, but that negative one needs to be moved to the right side. On the next one, we have x, y, z, and a constant, so that one's good. And the bottom has 3z on the left side, but then it has 2x and 5y on the right side. So those parts that I circled need to be moved to the other side. And just like we've been doing with solving equations, if it's on one side of the equal sign, if -1 is here and we want it on the other side, we need to cancel it. And in order to cancel it, we add 1 to both sides. So you end up with 1 on the right side. So this -1 is going to be a +1 on the right side. These right here, we're going to have equals 2x plus 5y, and those two belong on the left side. So we're going to have to cancel them on the right side. So -2x, -2x, -5y, -5y. So these cancel on the right side, and now they're -2x and -5y on the left side. So what we can do here is either just write it correctly as we see it, or rewrite the equations underneath. So imagine you're going to rewrite row 1. We're going to write it as 4x minus z equals, that -1 moves over, so instead of -1, it's going to be +1. So that's the row 1. And then row 3, it's going to become -2x, because that 2x belongs on the left side. So -2x, and if we go in order of x, y, z, we're going to have -2x. The y moves over, so instead of +5, we're going to have -5y. And then the z stays there because it's already on the left side. So plus 3z equals 17. So these two rows are the new ones for row 1 and row 3. So row 1, it's going to be 4. Well, remember, it's x, y, z, and then constant. So 4 for the x. There is no y, so we're going to put 0. There is a z, but now it's -1. And then the constant moved over, so now it's a +1. The second row was already in line, so we just had to write 1 for the x, 3 for the y, -2 for the z, and -11 for the constant. And the last row, we rewrote it. We moved the x and the y to the left side. So now we have -2 for the x, -5 for the y, and that 3 stayed on the left side. And then the constant is 17. So this is the matrix for this system. So once again, remember to write it in standard form, which is that. And then after you write it in standard form, then you write the matrix. Okay, so now let's reverse. You're given the matrix, and we're going to write the system. So the matrix is written in X, Y, Z, and the constant. So just imagine being an equal sign right here. So we're going to write 2x plus 5y minus 8z equals 12. 2x, 0 is for the y, so we don't write a y, plus 1z, or we just write z, equals 8. Negative 6x minus 2y plus 7z equals negative 24. So that is the system that was converted into a matrix. But we are reversing that process. We're given the matrix and you're writing it as a system. Okay, so the next one is x, y, z constant. So we have 1x plus 5y minus 6z equals 14. Then we have 0x, so we don't write an x. We have 1y, so just y, plus 8z equals negative 18. Then it's 0x, 0y, so the only one we have is z, so negative 7z equals 21. So this is the system that is written from that matrix. It's been about 12 minutes, so I'm gonna stop the video and then make a part 2, if you wanna watch it, for raw operations.